So that brings us to today's goals. What are today's goals? Today's goals are to get an understanding of arithmetic expressions so we can express ourselves in code, to also learn about using this thing called constants. You might know what a constant is in the real world. It's just some value that doesn't change. How do we think about that in Python and what do we use it for? And then also thinking about random number generation, because a little randomness goes a long way. I've never heard that phrase before, but just trust me, a little randomness will go a long way. So let's start off by thinking about arithmetic operations. So in order to do arithmetic operations, I need some numbers. Hey, someone gave me num1 and num2, two variables with values 5 and 2. And so what I can think about is what operations can I do on numbers? And so all the operations I'm going to show you, we can use on numeric types. We can either use them on ints or we can use them on floats. So on integers and real numbers, these operations all work. So what are some of the operators? Well, most of them you're probably familiar with from back in the day being like first grade or second grade or wherever you learned about all these things. First one is addition, right? The plus sign, you've already seen this. We added two numbers. And so if we were to have a new variable num3 that we said was equal to num1 plus num2, you could sort of say, well, what's num3 going to be? It's just going to be 5 plus 2. It will be 7. So over here in this column, I'm going to just keep track of what num3 would be after I do each one of these operations. So that's addition. And in addition to addition, we have our friend subtraction. And so subtraction, if we said num1 is num3 is equal to num1 minus num2, that's just num3 is equal to 5 minus 2, which, yes, you guessed it, is 3. Not a whole lot of excitement going on there, but we got more for you. You know, besides addition, subtraction, super important thing to do. One of my favorite operations, I have to say, in all of mathematics is multiplication. Also important for the species, because if the species, you know, say humans didn't multiply, we wouldn't exist. But multiplication. So if we say num3 equals num1 times num2, you're like, times, there's this little asterisk thing there. Yeah, here's the funkiness. Back in the days of yore, some point you probably learned that multiplication was like a big X, like that's how you multiplied. And then maybe if you got into algebra, you thought of multiplication as like a little dot, or sometimes you just put like one thing next to another thing inside parentheses, and that was multiplication. We don't do any of that stuff in Python. In Python, what we do is we use an asterisk character to represent the multiplication sign. That's actually true in a lot of programming languages. So it's not like Python is particularly weird. Most programming languages actually do this. So the symbol we use for multiplication is an asterisk symbol, which kind of just looks like a really fancy way of doing kind of the X for multiplication, but that's what multiplication is. It's the asterisk. So what this says is num3 equals num1 times num2. So that's 5 times 2. And so we would get 10. Ding. All right, so if you have multiplication, you're probably like, hey, Maron, we must have division, right? Yeah, we do have division. So division looks kind of like the way you think. It's got that little slash operator for division, kind of like you would think of fractions. And so if we say num3 is equal to num1 divided by num2, what we get is, what would you get if you divided 5 by 2? You would get 2.5, and that's what we get. And so notice what's going on there. What happened there is we had these two values, 5 and 2, and you might say, but both of these values, aren't they integers? Yeah, they are integers because there's no decimal point. But when I apply this operation, when I apply division, what I get back is something that is a real value, okay? So that's division. And you might say, there are some applications, though, where when I divide, I just want sort of the whole number of times that one number goes into another number. Is there a way to do that in Python? And there is. That is known as the notion of integer division, and the operator for that is actually 2 of these slashes for division in a row, so there's no space between them. This means integer division, and what integer division basically means is how many whole times does one number go into another number. So like if you remember back in the days of yore when you did division problems, maybe you wrote them like this, like 2 goes into 5, and there was something written like that, and you would write, well, 2 goes into 5 2 whole times, and that's what this gives you. So 5 integer division by 2 will give you back the value 2. So it gives you back how many whole times it went in. But if you also remember back in the day when you did division like this, sometimes there were remainders I loved it when there were remainders. Those are my favorite things. So you'd say 2 goes into 5, it goes in 2 times, but then you might put like a little R1 here to say, well, there was a remainder of 1, there was 1 left over. And then you might think, hey, can I get that remainder in Python, Maron? Yes, you can. And the operator we use for that is actually a percentage sign. Looks kind of weird, but we got to use the symbols we got, and that's one of the symbols we got. So we're just using the percentage sign, but that's what's used to mean the remainder operator. So what does remainder mean? So when I say num1 remainder num2, what it does is say take num1, divide it by num2, and give me back just the remainder. I don't care how many times num2 went into num1. What I want back is the remainder. And so there's a remainder of 1 here. And so that's what I would get as a remainder of 1. And I got to tell you, I love remainders. When I was a kid back in school and I was doing division problems like this and they didn't have a remainder, I would get upset because I was like, I want a remainder. What do you mean there's no remainder? So like I have a little place in my heart for the remainder operator. Probably a little bit more than I should, but that's just the way it is. You can pick your favorite operator, really. Everyone gets their own choice. There's also exponentiation. And exponentiation really is 2 asterisks in a row, because if you think about exponentiation like in a dark room for a long time, you're like, but it's just like multiplication of multiplication. Yeah, it is. And so we can represent that using 2 asterisks in a row. And the way we think about that is when we say num1 exponentiated to num2, that's kind of like saying num1 to the num2 power. And so this would be 5 raised to the 2nd power. It would be 5 squared, and that is 25. Ding. So you can also exponentiate. So those are your operators. There's actually one more you get that's actually an operator that only applies to a single value as opposed to combining 2 values. And that is the negation symbol, or also known as the unary minus, if you want to be fancy schmancy. I'm just going to call it the negation symbol. And basically it's if you take the negative version of a number. So if I say num3 equals the negative of num1, or num1 is just 5, and so num3 is going to give me -5. Okay. So you also have the negation operation, and Python can figure out negation versus subtraction based on, are you applying it to one thing or are there really 2 things involved when you're doing it? Okay. Now, one of the things you might have learned back in the days of yore too, when you were learning about all the different operations you could do, is there were these things called the rules of precedence. And what were the rules of precedence? The rules of precedence basically said, kind of like in life, some things have precedence. Some things just happen before other things. That may not be great, but that's just the way it is. And so in mathematics, there are certainly rules of precedence that some operations happen before other operations. And so how does that work in Python? So what I'm going to show you is the precedence of which operators happen first, or which have higher precedence, down all the way to which has lowest precedence. So the thing that has highest precedence, or the mathematics that gets evaluated first, is the way to think about it. If you have some expression with a bunch of stuff in it, and I'll show you an example of that in just a second, is you can always put things in parentheses. If you remember back from math, when you put stuff in parentheses, that meant evaluate this first. And you can have parentheses inside other parentheses, and the innermost parentheses get evaluated first. So that has the highest order of precedence. Then comes exponentiation. Yeah, that's one of those ones that most people just don't know offhand. Like, when did I evaluate the exponents? Well, they came after parentheses. Then comes the unary minus, or the negation sign. So when you negate something, that has the next order of precedence. Then all the things that kind of involve multiplication or division or remainder in some way, those all have the same level of precedence. So they all have the same level. If you have multiple of those symbols in some big mathematical expression, they're evaluated from left to right, but they all have the same level of precedence. And then after all that, the lowest level of precedence is actually addition and subtraction, which are perhaps our most important operators, right? If you think about it, if we didn't have addition, we pretty much couldn't do anything, at least mathematically, and probably in a lot of other things in the world. So like addition's down there, and it's like, I have the lowest level of precedence, and subtraction's like, I'm with you. So they got a little camaraderie, but they realize they basically carry all of mathematics on their shoulders, which is a beautiful thing. It kind of makes a tear well in my eye. And you're like, Maron, aren't you giving like personas to all these mathematical symbols and everything? Yeah, I am. Why? Because I think it's fun. And it's important to have fun when you're doing programming. So there is your order of precedence. And as I mentioned, operators in the same category of precedence are evaluated left to right. And you might look at these rules and say, these look kind of familiar. Aren't these kind of the rules of precedence in algebra more generally? They are. So if you're sort of a fan of algebra, you're comfortable with that, that's pretty much the same way it works in Python. So now you know that's precedence. Now let me give you an example just to make this concrete. So let me show you a little expression in Python and show you how it would get evaluated. So let's say a programmer came along and wrote this statement. So they wrote x equals 1 plus 3 times 5 divided by 2. And they didn't put in any parentheses. So Python's just going to take over and say, what are the rules of precedence? So first of all, it comes along and says, which operators have the highest precedence? Well, multiplication and division both are at the same level, and things that are at the same level, we evaluate left to right. So it says, okay, if I evaluate left to right, what is the first operator with the highest precedence is multiplication? That's the 3 times 5. So it executes the 3 times 5 and gets 15. What's the next operator to execute? Well, the division has the highest precedence now that remains, and so it does the 15 divided by 2, and I get 7.5. And then finally, remember our friend addition, along with subtraction, is at the lowest level of precedence. So even though we wrote it first on the line, it actually is getting evaluated at the end. So we would add the 1 at the end, and we would get 8.5. So if we executed this line, what we would get is our variable x over here would get the value 8.5. And if we wanted to evaluate this in a different order, we would put parentheses around it. But given the way it's written here, that's sort of equivalent to saying this gets evaluated first, this gets evaluated second, and then the whole thing, doing the addition at the end, gets evaluated last, right? So this is the first operator to get evaluated, is the multiplication, then the division, then the addition. And if you're like, but I want them in a different order, well, if you want them in a different order, just put the parentheses in, and Python will evaluate them in the order of the parentheses because they have highest precedence. That's one of the general principles I like to actually think about in terms of programming, is when you write a mathematical expression, if you're using operators and multiple levels of precedence, always parenthesize, because it just makes it clearer to the human reading the program what gets evaluated first, rather than having to remember all the precedence rules. Okay, so there's our friend precedence. Now, sometimes it also turns out that when you're working with mathematical expressions, sometimes you want to think of what are the types of these things, right? I have integers and I have floats, which are real values. What happens when I do these different operations to the type? Like, do they remain integers? Do they remain floats? What happens? Do they change sometimes? Because it looks like some of them change sometimes. So let's talk about what's known as type conversion, which is when you do these operations, what is the type of the result? So here are some numbers. I have num1, num2, and num3. Num1 and num2 are both integers because they don't have any decimal involved. And num3 here is a float or a real value because it has a decimal point. It's 1.9. So what happens when I do some operations? If I do an operation on two things that are integers or ints, except for division, but if I generally do something with two ints, then the result will be an int. So let me show you an example of that. Let's say I were to write num1 plus 7. So num1 we know is an int, it's just the value 5. If I add 7 to it, there's no decimal point here. So that's also an int. So 5 plus 7, when they're both ints, gives me 12 as something that's an int, okay? But if I divide two ints, I get a float. Because if I divide two numbers that are integers, I get a real value, even if one of the numbers divides the other number evenly. Okay, so the result of dividing two integers in Python is always a float or real value, even if the result is a round number. So if I were to write 6 divided by 2, what I would get is 3.0, which is a real value as the result. It just makes it easier to remember, though. Whenever I divide two integers, I get a real value. And if I divided two real values, I would still get a real value. Okay. So if either one or both of the operands, an operand is just a fancy name for saying the numbers that are involved in the operation, they are the operands, not to be confused with, say, someone who sings opera, which would be someone who sings opera. They wouldn't be an operand. If either or both of the operands are floats, then the result is a float. So if I add a float, say, to an integer, I will get, dun, 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 a float. Right, so num3 is a float, it's 1.9. Even if I add that to an integer, right, the result is still a real value. So what I get is 2.9, which is still a real value, it's a float. So if either one of or both of the operands are a float, then the result is a float. Okay. Now, exponentiation is the one place where things get a little bit weird. Okay. And in exponentiation, it depends on the result. So if I consider something where I have integers involved, and I say num2, which is the value 2 raised to the third power, right? That's just 2 to the third power. That's 8. That's an integer. But you might look and say, hey, can I do exponentiation with like negative exponents? Dun, dun, dun. Yes, in fact, you can. I just had to build a little suspense there. So if I were to say something like 2 raised to the -1 power, and remember, 2 to the -1 power is basically just 1 over 2, which is 0.5, and that's a float. So if you do something where the result is actually fractional or has something after the decimal point, you will get back a float. And that's oftentimes what happens when you do negative powers, for example. Not always, but generally what happens. Okay, so there is what happens with some of these type conversions, just so you know what's going on. That's known as implicit type conversion because Python is keeping track of all these types for you. It's doing it itself implicitly. In some cases, you're like, oh no, Python, I want to tell you what the type is. And that's what we refer to as explicit type conversion. And the idea behind explicit type conversion is you have a particular value, but you want to say, for this operation that I'm doing, I want you to treat it as though it were a different type. So how does that work? So the idea is if I had some value, say that was an integer or even a string, like a piece of text that had a real value in it, and I wanted to basically have it be evaluated as a real value, I would say float, and then inside parentheses, I would specify the value or the name of the variable that I want to have create basically a new real value or a new float. So what does that look like? If I were to say float on num1, num1 is the value 5 as an integer. When I say float of that, what I get back is 5.0. I get the float or the real valued equivalent, that's 5.0. I could assign that to a variable if I wanted to, but what I've now done is created a new value. I have not changed num1 in the box. Num1 in the box is still an int. I've created a new value, which is 5.0, which is a float, which now I could assign it to a box if I wanted to, or I could use it in some mathematical expression. Okay, so that's the important thing to remember, which is why I put it on the slide. It's that important, is that num1 is not changed. We've created a new value based on num1, but num1 itself is not changed. It's still the value 5 as an int inside its little box. These are still ints, and this is a float. Okay. So if I were to do something like, say, num1 plus the float version of num2, what would happen is the float version of num2 is 2.0, right? Because num2 is 2, so the float version is 2.0. So I say essentially 5 plus 2.0. Remember, if either one of the operands, either one of the numbers involved in the operation is a float, I get back a float. So I get back 7.0. You might say, but it's a 0.0, like, shouldn't that be an integer? No, because I converted this thing to a float. So when I do the addition, I'm adding an integer to a float, I get back a float or a real value. Okay, but remember, when I do this thing, when I say create the float, I am not changing the underlying num2. So if I now go and say num1 plus num2, I'm still adding 5 and the original 2, which are both still ints, and I get a 7, which is an int. Okay, because I didn't, by doing this float num2, I didn't actually change num2. I just said create a new value for the purpose of this one operation. Okay, and so you can also do the same thing with int, where if you apply int and then inside parentheses you have some value, you get the integer portion of that value. Okay, and the integer portion is basically if you had something with a decimal point, like you had some float, it just cuts off everything after the decimal point. So you're like, does it round? Is it nice? No, it just cuts off right after the decimal point. It doesn't matter what's there. That's how you get the integer portion. So if I get the float version of num3, the int version of num3. So if I say num3, I want your integer portion, what it does, it says that's 1.9. It does not round to 2. It says I cut off everything after the decimal, and so what you get is 1 as an integer. And this applies to negative values too. So if I say, give me the integer version of -2.7, it just cuts off everything after the decimal point and I get -2. So that's what's known as truncation. You sort of truncate or just cut off after the decimal point to create an integer value version of the number. And similar to what you saw with here with float, what using int does is it creates a new value. So when we say int version of num3 itself is still unchanged. It's a 1.9, it's a float, but I get back a new value, which is a 1 that I can now use in an operation or assign to a new variable or something like that. Okay. So if I were to say something like x equals int num3, I would create a box for x and that would get the 1 in it, which was an integer, but the original num3 is still unchanged. Okay. So important thing to keep in mind, especially for you science types who might want to be think about doing some programming that involves a bunch of numbers, which, you know, don't even need to do that much science to do some programming that involves into numbers, is that floating point numbers are real values, but they're not necessarily exact. So let me show you an example of that. So here's our friends num1, num2, and num3. At this point, they've all gotten to know each other very well, sort of like they're having a little party together because they're just like, woo, we're on multiple slides. Yeah, they are. Yeah, it's a good time. All right, so I could ask you, what is the type of num3 minus 1? So that expression, right? It's a mathematical expression. What is the type of num3 minus 1? So you look at that and you say, well, num3 over here, I know is a float. It's a real value because it has a decimal point. And Maron just told me like 2 slides ago that if either one of the values is a float, when I do an arithmetic operation, I get back a float. So how about I'll go with float, Maron, because you just told me the answer. And you would be correct. Good job, Maron. Actually, good job to you to figure it out before I told you. So the type of it is float. And now I could ask you the question, okay, so what is the value of num3 minus 1? And you're like, really? Really? You got to ask me, what is 1.9 minus 1? Well, 1.9 minus 1, Maron, is 0.9. Is it? Not what Python thinks. Python would tell you the answer is 0.8999999, whole bunch of nines. And you're like, but what? It's supposed to be 0.9. Well, it turns out because there's some imprecision when you want to represent real values inside a computer, some values Python can't represent exactly. So it uses the value that's real that is closest to the value you're trying to represent. So even though you know in your heart of hearts that 1.9 minus 1 should be 0.9, the best Python can do to represent it is 0.8999999. And so the key takeaway there is, what? Yeah, it can't necessarily represent all the numbers exactly. And you should just be aware of that when you're programming with floating point numbers. Sometimes there might be little errors because you're getting an inexact representation of the number. The way I like to think about it sometimes when you're up late at night and you're drawing pictures, when you realize you don't really have much art talent, is you get something like this. So there's our friend, Darth Integer. And Darth Integer comes along and says, I find your lack of precision disturbing. And over here, here's Princess Leia, who's a happy float, and says, don't be so negative, Darth Integer. Get it? Negative, Darth Integer. Get it? Yeah, I know. It's probably just not that funny. It's a pretty bad joke. It's not as bad as what Disney did to the Star Wars franchise, but it's still pretty bad. All right, let's move on. Let's talk about some expression shorthands. So what are some shorthands for expression? Sometimes it turns out there's some operations you're going to do so often that Python actually gives you a way to sort of lessen the number of characters you write, to have a little shorthand. So one of the things we often like to do is to add 1 to a number. So remember when we talked about the notion of assignment is we can actually have an expression like num1 equals num1 plus 1. And what this would do is it would say, well, if num1 is this box that starts off with a 5, what we do is we say, well, look up what's in num1, that's 5, add 1 to it, that would give us 6, and put that back into num1. So what we would get is a 6 in this box. That's the notion of incrementing a number or adding 1 to it. That is such a common thing to do in programming that there's actually a shorthand for it. And the shorthand says, just have the name of the variable, then say plus equals and the value you want to add. So if you want to add 1 to a variable and put it back into that variable, you just say the name of the variable plus equals 1. So these 2 lines are the same thing. Num1 equals num1 plus 1, and num1 plus equals 1 is the same thing. This just adds this 1 to num1, stores it back in the same place. And it turns out there's those kind of shorthands for many mathematical operations. So there's actually a minus equals. So if we wanted to say num2 equals num2 minus 4, so subtract 4 from num2 and put the new value back into num2, there's a shorthand for that, which is just num2 minus equals 4. And so essentially what that does is subtract 4 from the value of num2. There's a times equals, so same kind of effect if we were to say num3 equals num3 times 2, so you can apply these to ints or floats, either one works. What it does is say, essentially, if I say num3 times equals to 2, that's doubling the value of num3 and puts it back into num3. It says take the old value num3, multiply it by 2, put that back into num3. And we also even have a divide equals. It's a good time. Now, if you've programmed in some other programming languages before where the notion of adding 1, for example, there might be some other shorthand for it, which is like plus plus that exists in some languages. That does not exist in Python. So that's a habit you might need to break if you've programmed in some other languages before. The way you add 1 to stuff in Python is this with this notion of plus equals 1. Okay. And the general form, just to show you the general form for these things, is if you wanted to say something like a variable equals itself with some operator applied to an expression, that would be the same thing as having the variable operator equal altogether without a space and then the expression. So you might notice here that the expression that is being written on the right-hand side of the operator equal statement, actually when Python evaluates it, it thinks of it as putting parentheses around the whole thing. So if I had some complicated expression like num1 plus equals num2 plus 3, what Python would do is it would basically think about parenthesizing this and evaluating all of this expression before it then adds that to num1, just so you know how that works. Okay, so that's kind of one of the ideas there. And what we want to do with this is we want to put this all together now in a little program. So let's consider a little program that averages 2 numbers. So here's my program that averages 2 numbers in the development environment. So you can see at the top of the program, as we've gotten used to, there's a little comment that explains what the program does. This program asks the user for 2 numbers and prints out their average. Now let's go through the details of the program and see what's going on. And as you'll see, there's a bug in this program to begin with. We're going to figure out what that bug is and fix it so that we come away with a completely working program that also uses many of the concepts from expressions we just talked about. So inside our main program, what we do is the program starts by asking the user to get 2 numbers to be able to print out their average. So it prints out this program averages 2 numbers. Then it's going to ask the user to enter the first number. It does that through an input statement. So it's going to wait and ask the user to actually enter a number. And it's going to expect that number to be a real value or a float number, as we talked about, a floating point number, which is just a real value. And so the real value version of whatever the user inputs, that number will be stored in num1. Then we're going to do that same thing for num2. So we're going to ask the user to enter a second number. We'll get that via input. We'll convert that to a float or a real value number, and we'll store that in num2. And then what we're going to do is we're going to add the 2 numbers together and divide by 2 to take their average. And as you can see in the comment here, the way the code is written is buggy, so this is not correct. Let's run the program and see what actually happens, and we can identify the bug. And of course, the last step is to write out the averages and then what the total is or what that average was. So if we run the program, it starts off and it says this program averages 2 numbers. So let's pick 2 numbers that we can compute the average of pretty easily in our head if we could compute it correctly. Let's say we take the first number as 5 and the second number as 7. So what do you think the average of 5 and 7 is? Should be kind of straightforward, right? Well, it's 8.5. Is that right? No, clearly not. But how is the computer actually getting 8.5? Well, if we come back to our code and we remember the rules of precedence, right? Which arithmetic operations actually get executed in what order? When we come to this line for total, which is where the bug is, that's why I gave you this comment that it was buggy, we might be inclined to just evaluate it from left to right and say, well, we should add num1 and num2 together. That would be 5 plus 7, which would be 12, and then divide by 2, which we would think would give us 6. But that's not what actually happens. Remember, in the rules of precedence, division happens before addition. So what actually happens here is we don't add num1 and num2 together. The first thing that actually happens is this division. We take num2, which is our 7, and divide it by 2, which gives us the value 3.5. Then we add what's in num1, which is the 5, that's our first number, to the 3.5, and that's how we get 8.5. So if we want to fix it, what do you think we should do? And if you want, you could pause the video now and think about how to fix it, and then come back. So are you ready to fix it now? The way we can fix it is just say what I actually want to happen is I want the addition to happen before I do the division. And I can do that by parenthesizing the expression that I want to happen first. I just put parentheses around it, and that says do the addition of num1 and num2 before you divide by 2, and that will actually get rid of our bug. So let's run this version of the program to make sure that it's actually working right. And if we want to average two numbers like 5 and 7, our average is 6.0 as we would expect. Let's run it again and try it with some real values. Let's try, for example, to take the average of 3.2, which should be a fine real value, and negative 1.7. And what we get here, that looks kind of weird. In fact, it's not that weird. The average of 3.2 and negative 1.7, if you think about it, should actually be 0.75. But Python can't represent that number exactly. Remember, sometimes with real values, you get as close as you can to represent it, but some values can't be represented exactly. And so what we get is 0.75, 0, 0, 0, a whole bunch of zeros, and then the 1 at the end, which is as close as Python can get to trying to represent 0.05 exactly. So just remember that we don't always have exact precision with these floating point or real valued numbers. And the rules of precedence say that if you want some operation to happen before other operations, always a good idea to parenthesize it to make it clear. Okay, so with that, let me hop back over to the slides. So there was our program. Let me show it to you again now with the bug fixed. And so I have it here on the slide. And so you can see very explicitly, this is the fixed version where we fully parenthesized the fact that we want to add num1 and num2 first. And so that's the rule I would give you is it's always good to parenthesize so that the programmer doesn't have to think through in their head all the rules of precedence. It's just clear from how it's written, how the expression gets evaluated.